So we'll continue the things which we actually left from the octet rule. So octet rule says that there should be 8 elements in the outermost shell, or for smaller elements there should be 2 electrons in the outermost shell to be having to be more stable. The second statement of octet rule is that if they don't have an 8 electron in the outermost shell, or that means if they do not have octet configuration, then they should the atoms loses gains or shares electron, and they become stable. That means they are forming the bond, right? First statement is if they have 8, they are stable, they do not react, they are having octet configuration. But if they do not have 8, then they share, lose, gain, and try to become octet, and that means they're forming the bond. Whenever electron is shared, lost, or gained, and bond is formed. Please remember, bond is formed by sharing, losing, or gaining electron. So let's talk about the bond. Bond is, you can say that bond is an attractive force which holds the two atoms together. As you can see the example here, right? Oxygen, outermost shell atomic number of oxygen is 8, and 2 electrons and 6 electron. That means outermost shell of oxygen contains 6 electron. As it is unstable, having 6, it has 2 chances to become stable. It can lose all 6, or it can gain 2 to become 8. Which one is easier? Obviously the thing which is quicker will be easier, right? Because accepting 2 will be easier than again losing 6. Hence oxygen always gains 2 electrons, then only it will become stable octet configuration. So you will not find oxygen in the form of O, you will find oxygen in the form of O2 always, O minus 2, or any other forms in which oxygen is having 8 electrons. Example, I mean to say that water you take your water. Water is nothing but H2O, right? Oxygen is here. So one lone pair, two lone pair, and this will be, the bond electron will be shared towards oxygen, also towards hydrogen. That's why you can say that oxygen is always having two bonds because it accepts 2 electrons. So let's talk about the bond again. The example, the bond definition is, you can say that it is an attractive force which holds the 2 atoms together. So let's talk about the types of bonds. So we have 3 types of bonds: ionic bond, also called as electrovalent bond. Second is covalent bond. Third is coordinate covalent bond, also called as dative bond. Dative bond, also called as dative bond. So we have 3 types. Actually, there are many types of bonds, but we're talking about only 3 according to our syllabus, which is NEET, JEE Mains, and Eamcet. Even BitSet ke liye almost similar portion is there. You can even refer this for BitSet, as I can see that many of you are writing the BitSet also. So let's talk about in detail of ionic bond. So what is ionic bond? The simpler definition you have is the bond which is formed between 2 ions. The bond which is formed between 2 ions, right? Let's talk about the example. The example which we are very familiar with is your rock salt or table salt, which is NaCl. NaCl, that is sodium chloride, when in the form of solid. Solid means, when it's in the form of crystal solid, it will be not ionized. But when you dissolve in water like H2O, it gets ionized in the form of Na plus and Cl minus. That means the bond formed between sodium and chlorine is ionic bond, because after dissolving in water, they get ionized. Though in the solid form we don't write ions here, still we consider the bond which is between NaCl is ionic bond, because after dissolving in water, they get ionized. Ionic bonds are ionic only in aqueous state. Only in aqueous state. In the solid state, they do not get ionized. Please remember. So let's see why the sodium is getting so positive charge, why the chlorine is getting negative charge. So let's see the example here. Why sodium is getting positive charge. Let's talk about the atomic number of sodium. Atomic number of sodium is 11, right? 11 means first shell contain 2, second shell contain 8 electron, and the last shell contain 1 electron. Hope you know how to calculate the number. Hope you know that electronic configuration, the way of writing the electrons 281. That means sodium has a one electron in the outermost shell. What do you think? It's stable or unstable? It's stable or unstable? Unstable, right? Because it has only one. So sodium has two chances. It can lose one to become 8. It दे देगा 1 तो 8 हो जाएगा. Or it can accept 7 to become 8. What do you think? Which one is easier? The number is 1 and 7. So obviously, accepting one, losing one is easier for the sodium than gaining 7. Hence, sodium always releases only one electron. You will never find sodium in the form of Na plus 2, because if it loses this electron, it becomes 8. 8 means it has become stable after losing 1. So now you cannot find sodium in the form of Na plus 2 because it never loses 2 electrons. It only loses 1 electron. So after losing 1, the configuration will remain as 2 and 8. Right? Sodium has given electron to someone else. Someone else means it can be other element. Let's see what the other element. It can be chlorine. Atomic number of chlorine is 17. Just now I think I told you that. Please keep the periodic table attached to your chemistry notes or staple it to your chemistry notes. Don't leave your chemistry notes without your periodic table. Why? Because even by looking just periodic table, you can memorize many elements, even their configuration, which repeatedly ask in NEET about the electronic configuration of F block elements. That's why I'm mentioning you are forcing, specifying, insisting you to keep the periodic table, because NEET asks question only about the electronic configuration of F block. So we can't just lose 4 or 5 marks because of just that periodic table paper, right? It's simply a hard copy. Just get the hard copy and staple or stick it and try to memorize 1 to 30 elements. More than that also you should remember. But as of now, for initial thing, like for initially you require only 30. So let's talk about the electronic configuration for chlorine. That is 17. It becomes 2, 8 and 7. So now chlorine has 7, that means it lacks only 1 to become 8. So chlorine has two chances. Either it can lose all 7 to become 8, right? Or it can accept 1 to become 8 in the outer, this third shell. Which one is easier? Obviously, accepting 1 is easier. That's why chlorine always accepts 1 electron. You will never find chlorine in the form of Cl minus 2 minus 3, because it lacks only 1, right? It lacks only 1. It needs only 1. By it will it gain 2 electron. That's why the chlorine valency will be minus 1. So it will become 2H8. Now you can see that sodium has given that electron to chlorine. Chlorine is accepting that one electron. Sodium is giving that one electron. You can see that plus means giving of electron or losing of electron. Minus means gaining of electron. That means here there is a transfer of electron occurs. So actually the definition here for ionic bond is, definition for ionic bond, the bond formed by how the electron is is it sharing, losing or gaining? What do you think? Please answer. Is it sharing, losing or gaining? So I will answer here. I think you are late to answer. So the definition is the bond formed by transfer of electron. Transfer means one element is giving to other element. That means there is a gaining and losing occurring here, not sharing. Please remember, in ionic bond, sharing will not occur, only transferring, meaning gaining or losing will occur. The bond formed by transfer of electron, this is a short symbol I write for electron. Transfer of electron from where to where? From one element. I'll better do one thing. From one atom to another atom, isn't it? You can see that sodium is giving electron, chlorine is accepting electron. That's why we can say that is transfer of electron is occurring from where to where? From one atom to other atom. Let's be specific in writing the name of the atoms. So what is the one atom here? One atom which is giving here. You can see that the one atom which is giving here is the one which is acquiring electropositive charge. That means the one atom which is giving electron is known as electropositive element. So you go the handwriting, electropositive element. The one which is accepting electron is nothing but your electronegative element, isn't it? That means you can write down the one more definition for ionic bond, that is transfer of electron from electropositive element to electronegative element. So, and let's go in detail about this. Do you know the examples for electropositive element? Have you seen periodic table, how it looks? Do you know how it looks? I'm just drawing the block diagram here. This is S block, P block, D block and F block. Let me tell you that S block elements, S block element, D block elements and F block elements are electropositive. That means majorly P block elements are electronegative. Electronegative. Please go with the handwriting. It's difficult here. So what is the one atom which is giving here? Electropositive element. The element which is accepting here electron is electronegative element. One more thing about electropositive elements. All electropositive elements are metals. All electronegative elements are non-metals. Here when I teach chemical bonding and molecular structure, I'll also cover periodic table. Periodic classification, you know, right? Uh, you know that there's one more chapter in the chemical in the inorganic chemistry, which is periodic classification or classification of elements. So I covered that chapter in chemical bonding and molecular structure because that chapter is very easy. We have only certain definitions and all those things, decreasing, increasing things. So I'll be covering that chapter here in the chemical bonding only. So please listen carefully. Any doubts, ask in the chat box. So I think I told you the examples for metals. What are the examples for metals? Examples for metals are S block. Any S block you take, all are electropositive and are metallic. Any D block you take, they are electropositive and they are metallic. Any D block, F block you take, they are electropositive and metallic only. And the example for non-metal is P block element. So most of the P block elements are non-metallic, electronegative. I'm telling here most, not all. Okay. So I hope you got the definition for ionic bond, which is formed by transfer of electron from one atom to other atom. The one atom can be electropositive. The other atom will be electronegative. Electropositive elements are also called as metals. Electronegative elements are also called as non-metals. The examples for metals are S block, D block, F block. The examples for non-metals are P block. Right? So I can tell you the one more easiest way for remembering the ionic compounds. Any ionic compound you can make. If you have periodic table in front of you, you can do one thing. Mix any of the S block with P block element. Any S block you take, any P block you take, mix with them together and you will be, you will be getting the example of ionic bond. That means any S block and the bond between S and P is known as ionic bond. Any D block you take, mix with any P, the bond is ionic bond. Take any F block, mix with P block element, the bond is ionic. You can memorize, you can have the many examples of ionic bond, not only NaCl. You can make your own examples for ionic bond just by mixing NaS with P, D with P, F with P. That's all about this definition actually. Hope you are getting this. Not getting, please ask in your chat box. Is it clear? So how the bond is formed? Ionic bond, transfer of electron from electropositive to electronegative, or metal to non-metal, S to P, D to P, or F to P. That's all. So if you want, I can even give the example for S and P block elements. Choose any S block, mix with P as I said. So I want the S block element like cesium, okay, or like magnesium also I want. I can even take magnesium P block element is fluorine, chlorine you take, oxygen you take, or oxygen, fluorine, okay, oxygen will take. But you can't simply make them simply, they should be, transfer of electron proper way. The lost electron, the number of lost electrons should be gained by the gaining element, I mean electronegative element. Look here how to make the example. I want the combination between magnesium and oxygen means how many magnesium gives electron? It gives 2 electrons. Oxygen accepts only 2. So it is giving 2, it is accepting 2, hence the combination is best. When two ones are cancel them, it will become MgO. If you want the combination between magnesium and chlorine, magnesium always donates or loses 2 electrons, but chlorine accepts 1. As I told you that the number of lost electron and gain electron should be equal. That means magnesium is giving 2, chlorine is accepting 1, hence not balancing of electrons. So that's what we do. What do? We call the one more chlorine. ये एक और chlorine को हम बुला लेंगे क्योंकि magnesium 2 electron दे रहा, तो एक chlorine को देगा, दूसरा वाला chlorine को देगा. Hence, the formula will be MgCl2. I hope it is visible. MgCl2. Simple way of writing the formula is please crisscross their valencies. That means magnesium, if it is +2, chlorine will be -1. Hence, the charges will be like this. Crisscross the valencies. That means magnesium will be 1, chlorine will be 2. Hence, we got MgCl2. Actual way is this, but we can't think always this times. That's why for writing the formula fastly, crisscross the charges, you will get MgCl2. Right? Let's show the example of D block. D block, what? Zinc. We'll take zinc. Zinc always is +2. Negative element. What I want? I'll take nitrogen. Nitrogen valency is -3. So crisscross the charges. It will be Zn. It will be Zn3 and 2. That's the formula of zinc nitride. Oh, I'm calling as zinc nitride. Do you know how to pronounce these compounds? How to write the names? Probably I'll be teaching you how to write the formula, how to pronounce them in the next class, possible. F block, you take gadolinium, niobium, lanthanum, any you can take. You can just make the formula crystallize them. You will get the formula. So I hope you got the definition and as well as the way of making formulas and as well as the examples, many examples of ionic compound. I hope it is clear. So ionic compound definition is finished. Now the next thing we have is properties of ionic compounds. IC I'm writing, IC short form, ionic compounds or ionic bond properties. Ionic compound or ionic bond properties. First definition or the first properties, it is always formed between electropositive element to electronegative element, right? Obviously, one should be able to give, one should be able to accept. Then only the transferring of electron occurs. Then only ionic bond is formed. So ionic bond is formed between always electropositive to electronegative element. Second concept, it is formed between elements having high electronegativity. Please bear with the handwriting. Sometimes it is not possible to write properly here. So it is formed between elements having high electronegativity difference. I'm calling as END. What is END here? Electronegativity difference. What do you mean by electronegativity difference? The meaning is that there should be electronegativity difference between two elements. Meaning is that one should be able to accept fastly, one should be able to accept fastly. Okay, one should be able to gain and one should be able to last. देना चाहिए, कोई एलिमेंट देना भी चाहिए, कोई एलिमेंट लेना भी चाहिए. Then only electronegativity exists. I hope the second definition is clear. I can't even. So second point is between two elements, the bond which ionic bond is formed. The two elements should have high electronegativity difference, right? Ask me if you're not getting in a chat box. I can explain you in detail if you want. Right. So two differences. I mean, two properties are done. And let me tell you that one more very important property which the examiner is asking in your entrance exam papers. Ionic compounds having charges, right? Right? Charges means polar. Polar meaning nothing but ionic. The compound which have ions are called as ionic. One more word of writing this is polar. So please remember wherever you find charges, the compound is known as polar compound. Okay. Right. And do you know the compound which have charges will definitely carry current. Let's just go to about talk about conductivity. Current is only carried by two things. Current is always carried by two things, either by electrons or by ions. Only two things carries current, electrons or ions. Here you can see that ionic compounds have the ions, hence they carry current. That means are they good conductor or bad conductor? They are good conductor of electricity. Very important point. That means they are good conductor, but only in ionic state. Why I'm writing this here? But only in ionic state. Why we are telling here, specifying here? I think just before I think I told you here that whenever ionic compounds in the form of solid, they are not ionized. They will not lose gain electron. But whenever they are in the form of aqueous, when you dissolve water, I mean when you add water to them, they get ionized. That means only in the aqueous state they get ionized, not in the solid state. Let's write again here. They are good conductor only in ionic state, not in solid state. This was a question your examiner has asked in your entrance exam, like Eamcet, even they can ask in JEE and NEET. How the question was asked? They gave the four properties of the ionic compound. They asked you to identify which is a wrong statement of ionic compound. The three were right. One wrong was that conductor in solid state. Obviously, they are not conductor in solid state. They are only conductor in ionic state. Please remember this. That means wherever you find ions, tell them the polar compound. The compound is polar. Because of ions, they carry current. That means the compound is good conductor of electricity. And the next is the compound which are ionic, usually crystalline. You know the meaning of crystalline? Crystalline means they have the fixed geometry. The proper shape is seen in the microscope. If you see the ionic compound in the microscope, you can see the proper structure for long. Okay. Crystalline means that it will be crystalline even if solid. But if you see in the microscope, the shape will be proper and definite. We'll be having about the difference between crystalline and amorphous when we have a solid state chapter. Just as of now, please remember that it is having the fixed geometry or shape in the microscope. If you see in the microscope. So polar conductor and crystalline. And the last thing is, please remember the one more rule which we need to memorize here is like dissolve like. That means if the compound is polar, it is soluble in polar compound. If the compound is non-polar, it is soluble in non-polar compound. Like dissolve like means जो जैसा है वैसे को dissolve करेगा, right? Polar compound soluble in polar, non-polar in non-polar compound. As you can see that ionic compounds are polar, they are soluble in polar solvent. What do you think? It is soluble in water or insoluble in water? What do you think? Ionic compound is soluble in water, not soluble in water? To know whether it is soluble or not soluble in water, we should know which water is polar or non-polar. So what do you think? Water is polar or non-polar? Many of you knows water splits in the form of H plus and OH minus. That means it is ionic. Our water is ionic. Ionic compounds are ionic. That means they are soluble in water. Water का short form I'm writing, formula I'm writing there is H2. So few properties like it is polar, conductor, crystalline, soluble, and the very one more important property is the one which is soluble in water. Any chemical which is soluble in water will have definitely higher boiling point. BP here meaning boiling point. Chemistry में BP refers to boiling point. In biology, BP refers to blood pressure. So I'm just here teaching you chemistry. So please, BP here refers to boiling point. These are the properties, and the last is fourth. Ionic compounds have high lattice enthalpy. So what do you mean by lattice enthalpy? Do you know the enthalpy is a word referring to energy. So energy का दूसरा नाम I'm just writing as enthalpy. Properly let me write. High, more, lattice. Lattice is the word referring to 3D structure. What do you mean by high lattice enthalpy? Is that whenever ionic compounds are formed, they releases much more energy. Whenever lattice is formed, lattice means 3D shape of the element compound. Whenever the lattice is forming, whenever NaCl is forming, they release more energy. That energy which is released during formation of lattice is known as lattice enthalpy. That means ionic compounds have high lattice enthalpy means they releases more energy whenever lattice is formed. Right? Got the definition and you got the properties. I hope. Any doubts so far? Any doubts? Yeah, Sheikh, you are my old student, yes. So ionic compounds are finished. I talked about the definition, examples, then properties. I hope you don't have any doubt. If you have doubt, please ask in the chat box. Let's move to the next type of bond known as covalent bond. So let's see what do you mean by covalent bond. Was sodium, there in the ionic compound, sodium was giving electron because it had extra. Chlorine was accepting one because it had one less. That's why sodium was giving, chlorine was accepting. That's why there's a transfer of electron. What happened if chlorine is alone? If there's no one to give to chlorine, what happened? You know that chlorine has only 7 electrons in the outermost shell. It requires always one, but there's no one to give to chlorine. What is it? What it mean? It will do. So you know what they do? They one more chlorine is there. There will be not only one chlorine in the nature. There will be many chlorines surrounding. So one chlorine is unstable. Other chlorine is also unstable. There is no one to give to the both this chlorine. No one is giving this electron to chlorine. You know what they do? They do mutual sharing. They share their electron and they form the bond. Now just look here. This shared electron is shared by this electron, bonded electron is shared by two atoms. This chlorine and this chlorine. You can see that now 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This bonded electron is shared by two atoms. This type of bond which is formed by sharing of electron. Better we'll write the word mutual sharing. Why we are calling as mutual sharing? Because mutual is a word which is referring to, both are getting benefited. So this chlorine is also getting benefited. This chlorine is also getting benefited. Hence we say the mutual sharing of what? Electrons is known as covalent bond. If you want the one more definition, I can even make the one more definition here. The bond formed by donation by both or donated by both means both are donating, right? Chlorine is also, this chlorine is also donating, this A atom is donating, and this also B atom is also donating. Okay, both are donating and shared by both, donated by both, and shared by both. You can see that both are donating, both are sharing. That type of bond which is formed by donated by both, shared by both is known as covalent bond. So we have got two definitions for this, right? It's very easy. So you want examples? You want examples? The examples simply, it is always formed between non-metals and non-metals. Non-metal and non-metal. That means chlorine, chlorine. Okay. You can, like, even you can take the example of oxygen, but there will be two bond between two oxygen. Nitrogen के बीच में. That means Cl2, O2, N2. This type of bond which is formed between two atoms, which is, similar atoms, or which is formed by sharing of electron, is known as covalent bond, right? That means the element should be electronegative and electronegative. Then only it will be possible. But I have a question. Whatever question I'm asking, no one is answering. Why is it so? So I have a question. The bond between H and Cl is ionic bond and covalent bond. What do you say the nature of the bond? HCl has ionic bond and covalent bond. Hydrochloric acid or hydrogen chloride. The bond which is formed between hydrogen and chlorine is ionic bond and covalent bond. Please answer. Okay, I'll answer here. Let's see why it is so. Why it is mentioned here actually. The reason I mentioned here is atomic number of hydrogen is 1. That means it has only one electron in the outer shell, or you can even write here. Atomic number of chlorine is 17. That means 287, right? Hydrogen has only one. Chlorine has 7. As hydrogen is only one, it cannot give its electron to chlorine. If it gives, hydrogen will be lack, right? Lack of electrons. What they do again, they mutually share it. It gets 2, it becomes 8. I think just now in the previous I told you that octet rule के लिए for low there should be 8 electrons in the outer motion, or for a lower element there should be 2. So hydrogen is a lower element. If it has 2, it's also acceptable. Hence, by sharing of electron, hydrogen is becoming 2 stable, chlorine is becoming 8 stable. That means the bond which is formed between H and Cl is sharing bond, covalent bond. We misunderstand this that HCl is ionic bond. Reason is we found that HCl in the form of H plus and Cl minus. Oh, it is also showing ions, right? Why it's still not called as ionic bond? The reason here is the actual way the bond is formed between this H and Cl is shading, right? Shading is known as covalent bond. But why I acquired the charges? The reason here is look at the chlorine bond and hydrogen and chlorine bond. Tell me the difference between HCl bond and HCl bond. The difference is the two atoms here are similar. Here, right? That means there is no electronegativity difference between these two elements. If there is no electronegativity difference, no one will gain, no one will share, no one will lose. Hence, they mutually share. Here, chlorine, hydrogen. Two atoms are somewhat different. If two atoms are different, definitely there will be slight difference in electronegativity. That means this element have, between these two elements there is a zero electronegativity difference is there, but between H and Cl it has somewhat not high. If it is high, definitely they will gain, lose, ionic bond is formed. But between H and Cl, somewhat electronegativity is there. Hence, I'm writing as low electronegativity difference. So please remember that a covalent bond can be formed between elements having zero electronegativity difference if they are two similar elements. If they are two dissimilar elements, definitely low electronegativity difference will be there. And as you can see that two atoms is similar in the chlorine and chlorine bond. No one will gain, no one will share electron. Hence, charges will not be there. Hence, the compound is non-polar, isn't it? No charges. But as you can see that two atoms is not similar, hence there is a low electronegativity difference. So that's why, as chlorine is more electronegative, it tries to attract the electron toward itself more. It will not take the electron totally. It will just attract the electron toward itself. Hence, it develops partial negative charge. As hydrogen is giving, it develops partial positive charge. That's why, because of this charges, because of this electronegativity, low electronegativity, chlorine is acquiring the electron toward itself more. Hydrogen is giving an electron or losing the electron. That's why they are getting charges. They are, and if you break the bond, definitely chlorine will get totally negative charge, and chlorine hydrogen will get total positive charge. That means this is a polar compound, but it is polar ionic bond or covalent bond. It is polar covalent bond, and this is non-polar covalent bond. So indirectly I can tell you that we can say that covalent compounds are two types, or bonds are two types: polar covalent bonds, or compounds if you want to say compound, non-polar covalent compounds. That means there are two types of covalent compounds. The one which is polar and other can be non-polar. Polar means they will be having some charges, positive and negative. Non-polar means no charges, as they are having low electronegative difference. Low electronegative difference means no gaining or losing of electron. Hope it is cleared. If it is not, please let me know in a chat box, or even after watching these videos, you can even come back to the video. I mean, obviously when you are watching, you can ask the question in the live chat, chat box. That will be answered later, right? I hope it is cleared. Please remember there are two types of covalent compounds: polar, non-polar. The reason we are specifying here is there will be things related to this polar, non-polar compounds in detail. We'll be talking about later. Let's talk about the properties of polar compound and covalent bond. First thing, what do you think it is formed between? It is formed between elements which are electronegative and electronegative. That means it is formed between elements having low or zero electronegativity difference. So compound can be formed between elements which have low electronegativity difference or zero, but it should not be high. If it is high, definitely transfer of electron occurs, bond will be ionic. So as you think, you know that low means the compound is polar, zero means the compound is non-polar, right? Third one, what do you think? They are polar or non-polar? Majorly they are non-polar. Somewhat they are polar. In a broad sense, we say they are non-polar. Broad sense, you can even call them as polar, but polar compound are only very few. In the major category, like out of 100, 90, 90% is we say non-polar. The rest only 10-20% will be polar. That's why majorly we say non-polar. Even if you say polar, they are less polar than the ionic compounds. Uh, Non-polar means good conductor, bad conductor, non-conductor, right? Bad conductor, I mean, non-conductor of electricity. And what do you think? They are crystalline amorphous. They're not even crystalline, they're not even amorphous, they're usually gases. or liquids, majorly they are gases. Next, what do you think? It's soluble in polar, non-polar solvent. I think I told you that like dissolves like polar compound soluble in polar, non-polar in non-polar. So as they are non-polar, they will be soluble in non-polar only. That means it is insoluble in water. If you dissolve them in water, they will not get solubilized in water as water is polar. Water is polar and they are non-polar. And the compound which is soluble in water will have high boiling point. That means if it is not soluble in water, it will have low boiling point. I hope it is clear with the all properties which I have mentioned here, right? So I can tell you the one thing. You don't need to memorize these properties here. You do one thing. Simply remember opposite to the properties of ionic bond. All the properties of covalent compound are totally opposite to the ionic and covalent compound properties are totally opposite. You can even just check back when you're writing notes, just check the properties. There I had written high electronegativity difference. Here I'm writing low and zero. Polar, non-polar. Good conductor, bad conductor. Solids, gases. Insoluble, soluble. All those things. Is it clear? Let's talk about the last one, which is last ever bond, which is coordinate covalent bond, also called as dative bond. What do you mean by coordinate covalent bond or also called as dative bond? Let's see the definition for this. Uh, Before I talk about the example for coordinate CCB is coordinate covalent bond. Let's talk about the atomic number of boron. Atomic number of boron is 5, right? 5 means it has 5 electrons. First shell में 2, the second shell में 3. That means boron has only 3 electrons in the outer motion. So obviously according to octet rule, if they do not have 8, they are unstable, right? They are not having 8, that means they are unstable. So boron is unstable as it has only 3. So consider it has only 3 electrons, means it can only share 3 electrons and form 3 bonds. Look here. So boron was this. Hydrogen is coming. It is forming a bond with boron. You know, hydrogen has only 1 electron, that's why it can form only 1 bond. That's why we are having 3 hydrogens here. 3 hydrogens means there will be 3 bonds here. Now each bond contains 2 electrons, one is of boron, one is of hydrogen. You can see that is a mutual sharing here. Hydrogen is becoming 2 here after formation of bond. Hydrogen is becoming stable. But look at the boron. It had 3 only. That's why it formed 3 bonds. 3 bond means 1, 2, 3, 4, 5, 6. It has got 6 electrons. That means if I write BH3, in BH3, boron even after formation of bond is not having 8 electron in the outermost shell. Right? It had only 3. It formed 3 bond. Now, after 3 bond, it became 6 electrons. That because of 6 electrons, even after formation of bond, boron is not having 8 electrons. That's why we say boron is again unstable according to octet configuration. That means boron always BH3 will always be known as electron deficient species. Species is a word referring to molecules or anything. Electron deficient. If it is electron deficient, definitely it will accept electron pair, right? Electron pair it can accept now because it cannot give because it has already less. What is it can do? It can accept. So I can write as it can accept lone pair. Lone pair means 2 electrons. Lone pair accept that, isn't it? It will accept because it has less. Lone pair acceptors are also called as Lewis acid according to the Lewis theory. So BH3 it had only boron now became 6 electron. That's why it having less than 8. That's why it is known as electron deficient. Don't accept chart, Lewis acid. Now we'll talk about the element which is nitrogen. You will see why I'm talking about nitrogen. Nitrogen atomic number is 7. 7 means first shell mate 2, second shell mate 5. That means nitrogen has only 5 electron in the outermost shell, isn't it? That nitrogen is again unstable because it has only 5. So nitrogen, what does it do? It requires only 3, right? So now nitrogen is forming 3 bonds. Hydrogen is coming with electron, hence bond will be formed. You can see that nitrogen is forming only 3 bonds with hydrogen because it only required 3, right? So 1, 2, nitrogen now got 8. One lone pair, this is known as lone pair. 1, 2, 3, 4, 5, 6, 7, 8. Bond में 6 है, 2 electrons are extra, that is 8, right? That means whenever nitrogen is there, majorly it forms 3 bonds. That's why it always will have one lone pair, एक extra lone pair रह जाएगा उसके पास, right? You can see that nitrogen is having one lone pair. It looks like electron rich. Electron ज़्यादा है, right? It looks like electron rich. So I can write this molecule as electron rich. As it has one electron extra, which is not involved in bonding, it can share this electron to some other molecule which can accept. That's why sharer बोलना चाहिए, but we don't have the word sharer in a chemistry. तो लोन पे डोनर बोलोगे मैं. डोनर मीन देने वाला, but it's not donating here, it is sharing here, actually sharing here. The scientist gave donor, that's why I'm giving the word donor here. As you can see that electron rich can donate lone pair. They are known as electron pair donor. They are also called as Lewis base. BH3 is accepting, NH3 is donating. Now look here, the bond is formed. BH3 electron deficient, lone pair acceptor, Lewis acid. NH3 has one extra. It's giving his electron to this. Now you just see how the bond is formed. I am indicating the arrow towards boron or BH3. Indicating why. So nitrogen is giving, is accepted by B. Right? B, show the arrow towards element which receives. So BH3 is receiving here. Now you can see that this bond which is formed is again having 2 electrons. Right? It's shared by this also and this also. Right? But in this case, sharing is occurring. The one thing which is unusual here is, out of this 2 molecule, only 1 molecule is giving. That's why I say that this bond is formed by, donated by 1 and shared by both. Isn't it? Do you remember the previous definition for covalent bond? Covalent bond was mutual sharing, or I gave the even one more extra definition was donated by both, shared by both. But in coordinate covalent bond, donation is only by one molecule, which is NH3, which is Lewis acid, electron by donor, or which is rich, but shared by both. That type of bond which is donated by one, shared by both is known as coordinate covalent bond. The name says covalent. Covalent is a word referring to sharing. But it's coordinate. Coordinate is like cooperate. Someone is cooperating here. Who is cooperating? Which molecule is cooperating here? The one which is rich in its electron is cooperating. Nitrogen is cooperating with BH3. It's sharing its electron here. Here sharing is occurring covalent. As one is cooperating here, known as coordinate covalent bond. I hope you got the all definition for ionic covalent, coordinate covalent. Is it clear? Is it clear? So I can tell you the one more. We made the one definition. We can even make the one more definition for CCV bond. CCV means coordinate covalent bond or dative bond. The bond formed by the bond formed between actually Lewis acid and Lewis base or electron deficient. 2, electron deficient 2, or and you can write and electron rich, or lone pair do, here acid is acceptor, lone pair donor. That's all about the coordinate covalent bond. Lastly, we'll just yeah, properties you want. So any Lewis acid you take, any Lewis base you take, you will find the coordinate covalent bond. Oh, I'll tell you the very important and very easy thing. Many times NEET ask question about this. Do you want examples for Lewis acids? All Lewis acids are 13 group compounds. Any 13 group compounds you take, they are Lewis acid. And if you want example for Lewis base, they are 15 group compounds. Any 13 group you take mixed with 15 group compounds, you will find coordinate covalent bond, right? Many times asked question, identify which is Lewis acid, which is Lewis base. Any 13 group if you find, that is Lewis acid. Any 15 group you find, they are Lewis base. That's all. That's why I told you to keep the periodic table with you. So you can have the 13 group element with you, you can have the 15 group element with you. And if you have the periodic table with you, on the 13 group, top of the 13 group, write down there as Lewis acid, like example like this. So your 13 group here comes, right? Here you write Lewis acid, you write full form, I'm writing short form. Here you have 15 group, right? Above them you write Lewis base. That's all. Second type of most repeated kind of question is identify Lewis acid, Lewis base. Second sort of question which they are asking from this chapter is they're giving the compound and they're asking you to identify which compound has, this compound has ionic bond or covalent bond or coordinate covalent bond. I'll tell you that examples later. Let me just write down the properties and we'll finish this and we'll just practice few questions. Properties. No need to memorize any properties. These are the properties similar to covalent compound, covalent bond. Covalent compounds, coordinate covalent compounds all have the similar properties except one thing, that is boiling point. Ionic bond has a highest boiling point, then coordinate covalent compounds or bonds, then followed by covalent compounds. Boiling point is highest for ionic, then for coordinate covalent, then for covalent. That's all about here. Bonds. I hope it is clear. Let me just ask you the question which they are asking in entrance exams. So they're asking us to identify yeah, identify or pick up the one anionic compound. Let's give the options. Options are HCl, option B O2, option C F2, option D Be, beryllium fluoride. So please identify, those who are watching, please answer the first question, which is identify the ionic compound. Option A HCl, O2, B, C2, F, C, F, I mean F2, BCl, FBF. Please. क्लास में ना बैठा है क्लास ना बैठा है क्लास अच्छा जाओ तुम जाओ अच्छा ठीक है अच्छा ठीक हाँ अच्छा ठीक है ठीक है Please answer the first question. You're not answering. Why it is taking time? You're not getting the answer. Let's check the one which is ionic HCl. H atomic number is 1. Chlorine atomic number is 17, 287. So you can see hydrogen is having only one, chlorine requires one. But hydrogen cannot give because hydrogen has only one. That's why there's a mutual sharing occurs. Mutual sharing is known as covalent bond. Oxygen, covalent, fluorine, two similar atoms. No electronegative difference. If there's no electronegative difference, no one will gain, lose. They need to only share, right? That's why A, B, C cannot be the right answer. Only D will be the right answer. Let's see why. Beryllium is, atomic number of beryllium is 4, right? So 2, 2. Outer motion has an only 2. That means it can lose 2. That's why the valency is plus 2. Fluorine atomic number is 9. 9 means 2. 7. 7 means it can accept 1. That's why the valency for fluorine is minus 1. Beryllium is plus 2. That's why BEF. That means the bond is which is formed between B and F is ionic bond. I hope it is clear. I'm just telling shortly because I already discussed the definitions already. Right? Done? So they can give you any compound. They can ask you which of the following compound has ionic bond, covalent bond, like this. Right. Second, second sort of question they are asking in your entrance exams, which is damn important. Give 10 star marks whenever you are writing this in your books. I hope you are maintaining the notes which we are, taking in the online. So in your chemistry notes, right, in organic chemistry, the first chapter, chemical bonding, molecular structure. In that you write bonding, ionic bond, covalent bond, coordinate covalent bond. Write down again. Study. If you're not getting anything, let us know in chat box, or we have the doubt clarification apps also. Please ask. We'll clarify there. And yeah, when you're writing the notes, even write the question which we are discussing at the back side. And whatever the stomach are giving, very important. Ask questions. So you need to identify. The second question is you need to identify the Lewis acid. Option A, AlH3. Option B, CH4. Option C, SiH4. Option D is PH3. You need to identify which is Lewis acid. So please fast identify which is Lewis acid. Which is Lewis acid? LH3, CH4, SiH4, PH3. I need to answer this, right? Just go ulta, right? D se will start. PH3. Phosphorus. Phosphorus is 15 group. 15 group are Lewis base, I say it. Silicon. Silicon is silicon is which group? 14 group, 13, 14. Silicon, you can check in your periodic table that it belongs to 14 group. Carbon belongs to 14 group. Aluminium, boron, aluminium, gallium, indium, thallium, aluminium belongs to 13 group. 13 group compounds are Lewis acid, 15 group are Lewis base. Found the answer is A. So please do the questions which are based on Lewis acid and Lewis base. Similarly, they can even ask you the questions like Lewis bases. I hope the topic which I covered today is cleared. Not if it is not, ask in the chat box or in the doubt clarification app. Go to the app, write the question, upload that question page or question, type the question or write down in your notes and send it to the app. We'll clarify as soon as we can. So Kiran, I just saw your question late. Kiran, let me just answer you. HCl is a polar covalent bond. Why? I'll explain here. Why HCl is known as covalent, though it has ions. Ionic bond का actual definition is transfer of electron. Covalent bond का definition is mutual sharing of electron. The definition decides the nature of the bond. C. हाइड्रोजन हैज ओनली वन इलेक्ट्रॉन, क्लोरीन के पास 7 है, एक चाहिए होता तो अब बोलोगे आप हाइड्रोजन दे देगा तो क्लोरीन एक्सेप्ट कर लेगा तो H प्लस आ जाएगा, Cl माइनस आ जाएगा, यहाँ पे ट्रांसफर हो जाएगा. बट अगर हाइड्रोजन दे देगा तो उसके पास कुछ नहीं होगा, राइट. तो हाइड्रोजन देना नहीं चाहेगा, तो हाइड्रोजन एंड क्लोरीन क्या करेंगे, अंडरस्टैंडिंग कर लेंगे म्यूचुअली, दोनों क्या करेंगे, शेयर करेंगे इलेक्ट्रॉन. द बॉन्ड विच इज फॉर्म बाय शेयरिंग ऑफ इलेक्ट्रॉन इज नोन एज कोवेलेंट बॉन्ड. बट ये कोवेलेंट बॉन्ड है, इसके पास चार्ज क्यों आ रहा, पोलर क्यों है, बिकॉज दोनों दोनों आटम सिमिलर. जैसे आप क्लोरीन देखिए, दो क्लोरीन दोनों आटम सिमिलर है, राइट. टू आटम इज सिमिलर. दोनों के बीच में ना कोई देगा ना कोई लेगा, क्योंकि दोनों सेम आटम्स हैं. ना इन्हें देने के लिए इन्हें देने के लिए रेडी होगा, ना इन्हें लेने के लिए रेडी होगा, ये दोनों सेम ही है. मतलब दोनों के बीच में जीरो इलेक्ट्रॉन नेगेटिविटी डिफरेंस है, राइट. बट HCl में देखिए दोनों आटम्स थोड़े अलग अलग है, राइट. राइट. दैट मीन्स दो आटम्स डिफरेंट होने की वजह से थोड़ी इलेक्ट्रॉन नेगेटिविटी है, इसलिए मैं लिख रही हूँ यहाँ पे लो इलेक्ट्रॉन नेगेटिविटी डिफरेंस. इसकी वजह से इलेक्ट्रॉन थोड़े क्लोरीन के पास चले जा रहे, थोड़ा मूव हो जा रहे, टिल्टेड हो जा रहे, मूव हो जा रहे. हाइड्रोजन के पास हट जा रहे. इलेक्ट्रॉन किसी के पास ज्यादा है तो चार्ज आ जाएगा माइनस, इसके पास आ जाएगा प्लस. दैट्स ऑल. चार्जेस आ गए क्योंकि इलेक्ट्रॉन नेगेटिव डिफरेंस है, थोड़ा है, ज्यादा नहीं है. ज्यादा है तो इलेक्ट्रॉन ट्रांसफर हो जाएगा, थोड़ा है तो खाली थोड़ा मूव होता है उसके पास, इसकी वजह से चार्जेस आ गए. Hence we say HCl is a polar covalent compound, whereas Cl2 is a non-polar covalent compound. इसके लिए मैं बोली आपको covalent compounds दो टाइप के होते हैं, polar, non-polar. I hope it is cleared. It is clear that option D. My dears are answering here. I could not see actually your chats. Sorry, but right, that is right option for the A, first one, right. Do you want to answer one more question? Do you want to answer one more question? Lastly, we have, I think, 9 o'clock I'll finish. Don't worry. I had today 2 hours class, so I'll leave you by 9 o'clock. You can leave, but make sure that you write the notes in your you write the things in your notes, even the questions which I'm writing, as a practicing. Third last question, then you can leave. I want you to identify Lewis base. Option A, B, C, D. Let me just Chaliye. Last question, then you can leave after answering. Identify the Lewis base HF, GaCl3, gallium, GeCl4, BiCl3. That's C, that use of periodic table. So please keep the periodic table. Those who are not having, I know Kiran has and many of my students has, but those who have no, please, those who have no periodic table, please keep. See, many questions we can solve just by just periodic table and the concept which I discussed in the class. Last question, please answer, then leave. Only 2 minutes are there. I'm waiting for you people to answer. Then what happened, ma? Third one, please answer. No one is answering. Why? Please answer. Identify the Lewis base. HF, GaCl4, G, GaCl3, GeCl4, BiCl3. Oh, Kiran is answering. It's D. Really, it's D. Let me just check with the other students. What about other students? Please answer. I think Morera is there. Sheikh is there. Nitish Kumar is there.